we're doing order of operations and evaluating expressions. The power can be used to represent repeated multiplication. Addition is repeated, multiplication is repeated addition. Okay, 2 times 3 is 2 added into itself 3 times. Okay, 3 times 2 is 3 added to itself twice. You can think about it that way. Powers are repeated multiplication. Exponents. Tell how many times to use the base as a factor. In other words, how many times do you multiply that number times itself? Okay, 3 to the 5th power means you take 3 times itself 5 times. That's what exponents are. How many times do that? The base is the number or variable portion being raised to an exponent. To simplify, you replace a numerical expression with a single value. In other words, combine up all the numbers, do the arithmetic to take it down to a single numerical value. And then evaluate. Replace each variable with a given number and then simplify. This is often an important skill. You have a formula. You plug the numbers into the formula, you simplify it out to get your answer. It's a very common thing to do. Now, an aside, and something that's important to think about, order of operations. Okay, anybody hear about PEMDAS? I don't write it the same way that most people do. PEMDAS. Okay, you do what's inside parentheses first, parentheses, brackets, that kind of stuff. D is for exponents. M and D are for multiplication and division. I put them together because you do the multiplication and division at the same time going left to right. You do not go through and do all the multiplication and then go through and do the division. You do them at the same time. Whatever you hit first is what you do next. You multiply, divide, multiply, divide. You don't do all the multiplying and then do all the division. That is one of the most common mistakes students make. The other one is also with the AMS for the addition and subtraction. Once again, you don't go through and do all the addition and then go through and do all the subtraction. You do the addition and subtraction at the same time, moving left to right. These addition and subtraction are inverse functions, but they are essentially the same thing. They're the same operation. They're in that same family. We do them at the same time, left to right. Multiplication and division, same idea. They're in the same family. They're technically inverse functions, but they're in the same family, so you do them together. You don't do one and then the other. Another reason why I don't like PEMDAS is I get kids who, no, it has to be one, this, then the other. No, it's not. Multiplication and division. Addition and subtraction. Okay? So we got to be clear about that when you're doing these. Okay. So problem number 1, simplifying powers. 10 to the 7th means that I have 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6, 7. 10 times itself 7 times. That's what 10 to the 7th means, right? 7th power. I'm multiplying it times itself 7 times. Now, it's very easy when you're doing 10 to a power. 10 to a power is the easiest one to do because you have a 1 followed by 7 zeros. 1, 2, 3, 4, 5, 6, 7. 10 to the 5th is a 1 with 5 zeros. 10 to the 12th is a 1 with 12 zeros. 10 to any power is really easy to do. Yeah, I love it. It's the easiest one. Actually, it's not the easiest one. The easiest number to raise to a power is 1. Because 1 to any power is 1. Because 1 times itself, no matter how many times, is 1. Makes it really easy. Okay, 1/2 to the 5th power. Now, this one, I don't want to do 1/2 times 1/2 times 1/2. What I would like to do is think about this, and when you have fractions, it's the numerator to that power over the denominator to that power. So 1/2 to the 5th power is 1 to the 5th power over 2 to the 5th power. Well, 1 to the 5th power I already discussed is 1, because 1 to any power is 1. 2 to the 5th, okay. Now, you have calculators, right? Your calculators have exponent keys on them. I'll talk about that in a second. But some things you should be able to do without your calculator. And hopefully you can do as much as you can without your calculator, but if you need it, you need it. Don't get me wrong. But the more you can do without, the better off you're going to be in the long run. Powers of 2, count by 2s. 2, 4, 8, 16, 32. Powers of 2 are real common. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Okay. Powers of 2 are a big deal. If you ever want to get into doing programming or anything with computers, you really need to know your powers of 2, because everything in computers is based on powers of 2. Because computers only know 2 things, on and off. That's it, on and off. Your computer is a great big collection of light switches. A ginormous collection of light switches that are all turned on and off. The computer program tells you which switches to turn on and off. That's it. It's really all it is. Okay, if you break it down to its basics, that's all a computer is. It's a bunch of on and off switches. Very complicated system of them, connected up in very strange and wonderful ways, but that's really all it is. Now, 0.2 to the 3rd. Okay. So that's 0.2 times 0.2 times 0.2. But there's an easy way to do decimals. Okay. Just do the number like it is. Do 2 cubed. 2 times 2 is 4. 4 times 2 is 8. 2 cubed is 8. So I have 8. But it's not 0.8. I have 1, 2, 3 decimals, so I have to move it over 3 decimal places. So I have to go 1, 2, 3. 0.008. That's what it is. It's cubed, so I have 1 decimal place here. Cubed means I have to have 3 decimal places in my answer. And if I had 2 decimal places here, I'd have to have 6 decimal places in my answer. Okay. But once again, you may use your calculators. Okay? Please feel free on my calculators. There's a little key to let you do exponents. It's called, the technical term, it's not the exponent key. The technical term is the caret key. That's how you do exponents on my calculator. Most calculators are like this. They don't have this key, then they have one that looks like that. That's the exact same thing. So if you're doing them on your calculator, that's what you do. To do this one on your calculator, 0.2 to the 3rd, this is what you would do. You would type in 0.2 and then hit the caret key and then hit 3. And then do the equals and you would get 0.008. Okay? So you have calculators that will let you do this. Your calculators will do this for you. Do not rely on your memory. Don't guess. Work it out. I want you to be able to do them without your calculator as best you can. But if you need your calculator or use your calculator to check your work, feel free. Okay? Calculators are wonderful tools. They are not a replacement for doing the work. They are a tool to help you do the work. Okay? Does that make sense? Any questions so far? Okay. Next page. So, we have to simplify these expressions. What is the first step in simplifying these out? What do I have to do first? Parentheses. Do what's inside the parentheses. So my first step on this one is to do the 6 minus 2. So I get 4 cubed divided by 2. What's my next step? What do I do next? What do I do next? I've got it written on the board. What do I do next? What's my next step? Thank you, exponents. Okay, so that means I take 4 to the third power. 4 cubed is 64 divided by 2. Now I do the division because there's only one thing left. The only thing left to do, I've got to do the last thing to do. 64 divided by 2 is 32. Half of 32. Okay. Okay, the next one down. 2 to the 4th minus 1 divided by 5. What do I do first? What? Exponents. Exponents first. 2 to the 4th. 2, 4, 8, 16. 16 minus 1 over 5. Okay, what's next? I heard division. Okay, which is next on the list. However, this is a little bit different. And I'm glad that, this one's up here because when I have a fraction set up like this, I need to simplify completely the numerator and simplify completely the denominator before I do the division. Fractions like this are kind of like the top's in parentheses and the bottom is parentheses as well. So it's kind of neat to treat it like they're in parentheses before I do my division. It's a little unusual, but you can think that, hey, I've got this going on. I've got to do this part before I can do my division. Okay, I've got to do whatever's in the parentheses first before I do my division. It's a little unusual. So I get 16 minus 1 is 15. 15 divided by 5. Okay, last example, then it's your turn. What do I do first? Do the exponents first. 5 times 7 minus 4 squared is 16 divided by 2. Okay, so I've got no parentheses, got no more exponents. What do I do next? The multiplication and division at the same time, left to right. So I do 5 times 7, 35 minus, I do this, minus that, which is 8. Do my multiplication and division at the same time going through. And now I only have one thing left. I do that next 35 minus 8 is 37. Thank you. Show off. Okay. Questions? Basic order of operations. That's what this is about. Please, like I said, free use calculators to help you on this, particularly the exponents, because those numbers can get big in a hurry. I know what 4 cubed is because I'm doing this stuff forever. Okay, I use it in a lot of different places. I've got it down pat. If it had been like 7 cubed, probably would have pulled out a calculator to do. Okay, just one of those things. So your turn. Okay, let's go ahead and do these two. So on the top one, on the top problem, my first step would be to do the exponents. So I have 8 plus 3 cubed is 27 over 7 minus 2. Now I can't do the division until I simplify the numerator and the denominator. So I go to do that. I do the numerator is 8 plus 27, which is 35. 7 minus 2 is 5. And then I can do my division and I get 7. Okay, on the next one, what do I do first? What do I do first on the next one? Multiplication, division goes before subtraction. So 12 minus, what's 25 divided by 5? 5, what's 12 minus 5? 7. So in answering the question here, what did I do first? Division. So where would I put my parentheses in this in order to signify doing that one first? Around the 25 divided by 5. Okay. Okay. What? Did all that. Okay, now we're on to this one. Okay, so next thing, evaluating algebraic expressions. Okay, what is the value of the expressions for x equals 5 and y equals 2? I take 5, guys, take 5, plug it in for x, take negative 2, plug it in for y. So I take 5, put it in for x, so I have 5 squared plus 5 minus 12 divided by negative 2 for y squared. First step whenever you're doing evaluation, just plug the numbers in. Plug them in first. Don't simplify until you've written it down with the new numbers plugged in. Now you do order of operations and figure it out. Okay. 5 squared is 25. Negative 2 squared. What is negative 2 squared? Positive 4 because it's negative 2 times negative 2. So it's 4. And then the next thing I'm going to do is my division. 12 divided by 4. So I have 25 plus 5 minus 12 divided by 4 is 3. And I work addition, subtraction, left to right. 25 plus 5 is 30. 30 minus 3 is 27. On this one here, it's the same thing. I have 5 for x and negative 2 for y. So this is 5 times negative 2 squared plus 5 times negative 2. Notice I put the negative 2 in parentheses. So I do not confuse myself and think that I have 5 minus 2. So I'm not confused about what's going on. If I have a negative 2 for substitution, I put that negative thing in parentheses. It helps keep it simplified so I don't get confused with what's going on. And now I work my problems. First thing I do is what's inside the parentheses. 5 times negative 2, that's negative 10, still squared. Plus 5 times negative 2, that's negative 10. Plus 5 times negative 2 is 10, and 5 times negative 2 is 10. bring it up. So you can just put the work log on my desk. I'll take care of it from there. Now, next thing I do is the exponents. I take negative 10 squared. What is negative 10 squared? 100. Positive 100. So I have 100 plus negative 10. So my answer is 90. Questions on that? Your turn. Do those two. Let's do these two. So A is negative 3, B is 4. So the first one, I have 3 times 4 plus negative 3 squared. I get 3 times 4 plus 9. Negative 3 squared is 9. 3 times 4 is 12. So I have 12 plus 9, which is 21. This one, same idea. I have 2 times B is 4, so I have 2 times 4 squared minus 7 times negative 3. First thing I do is exponents. 2 times 16 minus 7 times negative 3. Now I do my multiplication and division going through left to right. 2 times 16 is 32 minus 7 times negative 3 is negative 21. Yeah, and so because I have subtracting a negative, what do? I change that to adding a positive, add them together. The answer is 53. Watch your negatives and positives. That's going to be the biggest issues on these. Wow. Pay attention to your positives and negatives. Easy to screw them up. Okay, last one. Evaluating a real-world expression. Write an expression for spending the money you have left after depositing 2/5 of your wages into a savings account. There are 2 expressions we can use to figure out how much money we have left. Okay. So we have, excuse me. Okay, gentlemen, ladies, control. Thank you. Okay. So we're actually going to use this table below, but we have to come up with the expression first. We're given what our variable is going to be. Our variable is going to be W for wages. What I want to know is how much money do I have left? So I start with what I get paid, and I subtract from that what I deposit. And I deposit 2/5 of what I got paid. Now, this is a workable expression, but it is not the easy one. If I have my wages, and I take 2/3 and deposit, how much? 2/5 and deposit, how many fifths do I have left over? 3/5. Right? 2/5 I deposit means I have 3/5 left over. This is the same thing as 3/5 W. Because if I have a big pot of money and I take 2/5 and put it here, I have 3/5 left over. I got $5, I put 2 in and I keep 3 out. Right? This is an easier expression to work with than this one. And we want to do things the easy way, do we not? Yeah. So when we work this problem, our expression we're going to use is we're going to use 3/5 W. So if I deposit $40, then the amount of money I have left is 3/5 of 40. Okay. Now, what do I have going on here? 3/5 and 40. If I take a look at this, and I'm going to write off to the side here, I have 3 divided by 5 times 40. I have, what do I have going on? I've got multiplication and division. It doesn't really matter which one I do at this point in order to do it. I can do 3 times 40 and divide that by 5, or I can take 40, divide that by 5, and multiply that times 3. Either way will work. You have your calculator. Let your calculator do the work for you. Okay? So when I work that out, 5 goes into 40 8 times 3. I got $24. I put 16 in my savings account. I got 24 to spend. Not a bad deal. You want to put some money aside. If you can put some money aside in case something comes up that you really want to get, if it's expensive or an emergency happens or whatever, that's what you should do. Okay. So my expression in this one, 3/5 of 50. And then I figure out what that is. What's 50 divided by 5? 10. What's 10 times 3? 30. Here's what I want you to do. Do the last 2 problems. Fill in the last 2 problems on the box. Okay, so first thing you do, fill in the expression, 3/5 times 75. 75 divided by 5 is 15. 3 times 15 gives you $45 to spend. Okay, the more money you make, the more you get to spend. And then 100. 3/5 of 100 ends up being how much? $60. $60. Not too bad, I hope.